Welcome to the ET322 Basic Linear Power Supply Lecture. Our AC to DC power supplies start with a sine wave, an AC signal. And taking a look at our sine wave, we have different measurements. We have peak to peak, Vmax, and VRMS, root mean squared. And that is an arithmetic average of the area under the curve. I'll show you that here in a second. Here we're showing the AC sine wave and the RMS equivalent. The RMS equivalent would be the equivalent DC power of an AC sine wave, so it's going to be an average. And it's just about 0.707 times the voltage peak max. In order for us to build a DC power supply, we have to reduce the wall voltage from 120 volts AC, which is RMS, down to a lower ratio, a lower voltage. So what we do is we use a turns ratio. There is a primary winding and a secondary winding, and the ratio of those two make the transformer either step up or step down. So step up would increase the voltage, step down would decrease the voltage. And it's an inverse relationship. If the voltage goes up, the current goes down by the same ratio. Here's our first and most simple power supply, a half wave rectified, where we use a transformer and a single diode. And what we get is this inverse part here of the sine wave, the lower sine, is eliminated, and all we're getting is the top part of the sine wave, and our voltage is reduced because of that. And this one's a little more difficult to filter, but it's very simple, only one diode. Here's our next one, a full wave rectified, and this one uses two diodes and a center tap transformer. So we have to get a more expensive transformer because we need a center tap and another diode. But what we're doing is we're getting an additional half sine, which makes it easier to filter. And unfortunately, because of the center tap, our voltage is reduced by half. So what we get with better filtration, we lose a little bit of voltage. And our last and most complicated is a bridge rectifier power supply. And what we have is a diode bridge of 4 diodes, and they're set up in a certain way in order to inverse our sine wave, but we're going to get the full voltage out, and we're going to get the complete half of our sine wave back. And this is the most common, and these parts are relatively inexpensive nowadays, so this is a very easy one to build.